In this paper, we present a model that de-renders a single image of a rotationally symmetric object, such as a vase, into shape, albedo, material, and environment lighting, which capture diffuse and specular effects. This allows for applications including free viewpoint rendering and relighting. Most existing methods only recover diffuse materials. Other methods that consider specular materials rely on synthetic data or require multiple images from different viewpoints or with different lighting as supervision during training. Unlike these approaches, our model is trained using only single image collections with silhouettes, without any explicit 3D supervision or multi-view, multi-light images. Note that the silhouettes are obtained from off-the-shelf object segmentation techniques and are not required at inference time. Since this is an extremely ill-posed problem, we make simplifying assumptions on the geometry and focus on rotationally symmetric objects such as vases. The shape of these objects can be described by solids of revolution, which are generated by rotating a plane curve about the axis of revolution. In our model, we simply use a discretized radius curve to represent the shape. To train our model, given an input image of a vase at training time, we first predict the shape of the vase as a solid of revolution as well as the camera pose, and train the network to minimize the loss on the rendered silhouette. We then use the predicted shape and pose to unwrap the surface texture of the vase and predict environment lighting, surface of material, and diffuse albedo. These components are combined to render a reconstruction of the original input image, which allows for end-to-end training of the whole pipeline with an image reconstruction loss. To encourage the model to disentangle albedo and lighting, we minimize a second reconstruction loss on another image rendered using a single color mean albedo map. So far, the reconstruction losses only encourage faithful reconstruction of the input image. It does not guarantee realistic albedo prediction, especially in regions saturated by the specular reflections. We therefore propose a novel self-supervised albedo discriminator. The idea is that if we feed random albedo patches to a discriminator, it should not be able to tell whether they come from a specular or non-specular region. Specifically, we randomly sample patches from the predicted albedo and sort them according to the variance of their specularity. We then feed the top and the bottom groups of albedo patches to a discriminator and train our model to prevent the discriminator from telling apart these two groups. Note that our SAD does not require any real albedo images for training, hence the name Self-supervised albedo discriminator. With all modules combined, the whole pipeline can be trained end-to-end to recover shape, lighting, material from only single images, without any explicit 3D, multi-view, or multi-light supervision. Here are some results of our model, trained on a museum vase collection. Given each input image, our model recovers shape, diffuse albedo, diffuse shading, specular shading, material property, and environment illumination. Here are some more results. We conduct ablation studies to understand each loss term. In particular, the model without the single color albedo rendering loss fails to decompose the albedo in lighting, and the model without the self-supervised albedo discriminator produces artifacts in the albedo, especially in the specular regions. Once we have these de-rendered components, we can re-render the vases from different viewpoints or change the lighting conditions. Although our model is trained on museum vases, it generalizes reasonably well to vases in internet photos. Thank you for watching.